Hello friends, today I will discuss about broken conductor protection in case of distance relay. So before going to this video, you are requested to please go through my channel and do subscribe my channel if not subscribed earlier, and press bell button for notification of videos to be uploaded in future. So before discussing about the broken conductor protection, let us discuss about the most common type of fault that actually happen in case of transmission line. So most common type of faults are single line to ground fault. Single line to ground fault may occur due to tree touching bottom conductor. Most of the cases it is bottom conductor touches the tree branches, and that is why single line to ground fault occur. Again, another type of single line to ground fault that may occur, that is the flashover in the disc insulator due to in foggy season. And it may be the back flashover of the disc insulator due to lightning stroke. Again, it may be a double line to ground fault due to tree branch touching any of the two phases, or it may be a three-phase fault or three phases to ground fault. So all these three types of faults are called actually shunt fault. So all these types of fault are basically shunt fault, and this type of faults when happen at the fault point, current will increase and voltage will decrease. So the distance relay will easily detect this fault by means of the V by I ratio, that is by means of the impedance or setting which is given to the relay. So apart from the sun type fault, another type of fault which is exist, which is called series fault. So this type of fault can arise from the broken conductor or broken jumper or maloperation of the single phase switch gear. For example, we have a circuit breaker. During closing of the circuit breaker, one of the pole does not make its contact. So due to this, broken conductor may happen. So load current will flow in the healthy phases, but no current will flow in the broken phase. So this type of fault is not easily detectable by means of the distance relay or by means of the backup overcurrent relay. Now for distance relay, at the fault point, the current will increase, and at the same time, voltage will decrease. But in this type of fault, voltage remain as it, that is, voltage remain as per healthy phases, but there is no current. So it is not detectable by means of distance relay. And again, for overcurrent relay, since there is no increase of the current, so it is not detectable by the overcurrent relay. Again, for earth fault relay, since directional features is given to detect earth fault, so the voltage is remain as it was for healthy phases, so it is not detectable by the directional features of the earth fault relay. So how to detect this type of series fault? So one of the method is by means of the negative sequence current detection method. So by means of negative sequence current setting, this fault can be detected. So let us take example. For example, a transmission line has a CT ratio in one end of the substation. For that line is 800 by 1, and 1 per unit current is equal to 800 ampere. Or you can say 1 ampere secondary current is 1 per unit, and in primary value is 800 ampere. So in order to calculate the sequence component of the current for balanced load, let us consider that that full load current is flowing, and due to the flowing of the full load current, 1 per unit current is flow in the relay for each phases. So due to this, we will calculate the positive sequence current, negative sequence current, and zero sequence current based on formula given to this Excel. So I am not showing the formula for this since the 1 per unit current is flow in each phases, and all the current is in balanced conditions. Positive sequence current comes as 1 per unit, and there is no negative sequence current component of current and no zero sequence component of current, since all the phase current are in balanced conditions. Now consider the rate phase jumper is open, which resulting in a series type of fault. So due to opening of the rate phase jumper, the rate phase current will 0 and other phase will carry the current of the same amount. So here IB and IC is 1 per unit and IA is equal to 0 per unit. So here the positive sequence current comes as 0.67 per unit and negative sequence current comes as 0.33 per unit and zero sequence current component comes as 0.33 per unit. So in terms of primary value, the negative sequence component of the current is 0.33 into 800, which comes as 266.6 ampere. Now let us take another example, that is the rate phase jumper is open, creating the series type fault, but here the load is only 10% of the 800 ampere of full load capacity of the transmission line. So here the load current is only 0.1 per unit. So here IA is equal to 0 per unit, but IB and IC is 0.1 per unit. So in this case, positive sequence component current comes as 0.07 per unit and negative and zero sequence component of current comes as 0.03 per unit. So the value of the negative sequence component current in terms of the primary value comes as 0.03 into 800, which is 26.6 ampere. So due to low load conditions, the setting given in the relay, it is very hard to detect this type of fault by means of the negative sequence relay setting. So instead of by means of the negative sequence current, one setting which is given in the distance relay, that is the I2 by I1 ratio. That is the ratio of the negative sequence to the positive sequence component current. So let us take the same load current, that is 10% of the full load capacity of the transmission line is current flowing. That is zero point 0.1 per unit current is flowing for all the phases, and during this condition the rate phase jumper is open, which is creating series type fault. So the positive sequence current comes as 0.07 per unit and negative and zero sequence component of the current comes as 0.03 per unit. So the ratio of the I2 by I1 is comes as 0.03 divided by 0.07, which comes as 0.429. So this type of fault easily detectable by means of the negative to positive sequence component of ratio, and this type of setting in distance relay is called as broken conductor setting. So series type of fault are better detected by means of the I2 by IY ratio, which is given in distance relay as a broken conductor setting. Normally in distance relay, it is alarm is given in case of a broken conductor setting in distance relay, or sometimes trip can be given depending upon the conditions or depending upon the utilities. So, so this is how the broken conductor in distance relay detect series type of fault. So friends, if you like my video, then do subscribe my channel, and thank you for watching my video. Thank you.